Okay, I think it's about time to start our final session of the day. Um, so our first speaker, first of two, will be Todd Tannenbaum. Todd is the architect of HTCondor at the CHTC, and he's going to be telling us all the things that are going to be coming up for sure, 100% guaranteed uh, in upcoming versions of Condor. So take it away, Todd.
For sure, 100% guaranteed, says Greg. All right, let's see if this works. All right. Long day. I will try to move this along. I've quite a bit of material. Hopefully the day has been informative and instructive for folks. So I am going to talk about what's new and what's coming up in the HTCondor Software Suite. I think Janet gave my talk on the schedule a much fancier name, like HTCondor Flight Path or something, which is way more creative than I was able to do. So first, a public service announcement. Who here uses the HTCondor users email list? Probably like 2/3 or more. That's wonderful. They're moving. June 22nd, we are moving all of our email lists to Google Groups. So in a way, that's good news, because I would argue Google Groups has better searching capabilities than our ancient department mailman server. But our mailman server in the computer science department here is being shut down. So my guess is Google Groups will work a lot better than a shut down mailman. The good news is if you're currently subscribed on HTCondor users, you won't have to do anything. Those subscriptions will move, but just so you're not alarmed to see getting email from some Google group, it's Condor users. We're also taking that opportunity to rename the poorly named Condor World email list to HTCondor Announce, which is really what it's used for, is announcements of new versions or security problems. So another quick public service announcement. We talked about this last year, but it's worth repeating. If you're still on HTCondor version 24 or older, there are new defaults in version 25 and above that might be surprising. A big one is if you use the Python bindings, you should be importing HTCondor 2, the new version of the Python bindings. They're very, very, very compatible with the old version. And so you would do, for instance, import HTCondor 2 as HTCondor, and for most people, that's good enough. Partitionable slots are enabled by default. Anybody in here, by show of hands, still use static slots? Great. Seems like a good default then. And a few other maybe surprises are up there on the board. GPU discovery is automatically enabled, so your GPUs will be published in the start the ads by default unless you say otherwise. HTCondor 26. We are currently on version 25.11 of HTCSS. We have been averaging about a new release practically monthly. So 25.14 in August or September probably will be the last one in the 25 series. That'll be the release candidate for HTCondor 26, which we expect sometime September. We'll aim for August. We'll probably end up being in September. Platforms added to the list are up on the slide. One of note is NVIDIA DGX. We have some DGXs in CHTC. We're excited about them. We might even run them in the classical HTCondor of old way, which is kind of a desktop scavenging role. It could be that the NVIDIA DGXs will be popular for desktop scavenging. By show of hands, people know about the NVIDIA DGX? So about half. So the DGX is a tiny little workstation from NVIDIA that is geared for AI work. It's basically has a unified memory model where all whatever 128 gigs or more of RAM can be used by either the CPU or the GPU. It is fast. They can compile Condor from scratch, all source code in about 42 seconds, which is impressive. And that's not even using the GPU. And thanks to hard work from Zach, is Zach in here? Zach, oh, they're right there. Contribution from Zach, we can actually run it in desktop scavenging mode because Zach contributed support for Wayland. Previously, our detection of keyboard and mouse activity relied on X11, and X11 is yet another project that's about the same vintage as Condor that is no more, but Condor keeps going. So platforms removed from support are up on the list. These are all old operating systems that are near end of life. If you're running one of these, talk to us. So since HTC25, there's been about 30 releases, like I said, about one a month of both the feature series and the long-term support series. Lots of new features. I'm not going to go over all of them, but they're all on the web. You can get highlights of all the new enhancements at this link. And then, of course, the manual has a blow-by-blow version history. When you go about upgrading, we have a section in the manual that talks about upgrading from 25 to 26 or 24 to 25 with the gotchas administrators and users might want to know about. And we also have a tool called Condor Upgrade Check. This is for people who don't like to read, but just want to run something. And that'll basically scan around in your configuration and check for all the things the manual tells you you're supposed to check for. So having the what's new, what's coming up is it's a difficult talk to give because times are changing quickly, especially in this age of AI. What's a big priority this month might be a very small priority 2 months from now. And then I'm accused of, telling lies, Greg, or having people like my director refer to my talk as the talk of lies, Marone. This is it's a tough place to be. So why not embrace? This talk will be mostly truths, but there will be some lies. So you got to stay on your toe and try to see if you can identify the truths from the lies. There are many truths. And a few lies. So on Tuesday, and Peter Kavaris, our incoming executive director, is that his title? Executive director, kind of gave it away in the chat because he was talking about it because he's very excited about it. But on Tuesday, Marone said we can't control the weather in his talk. And he was being a little modest because in Condor version 27, we do control the weather. And this would have been extremely handy to have this week, especially given all the rain. And of course, we have a new daemon, the weather D. You just set a couple config knobs, including your desired forecast, and you got to open your port 9618 to the troposphere. That shouldn't be too hard to do. And it's great. No more cooling problems. Make a cold front right over your hot running GPUs. Make it sunny and warm where you sit and administrate. And of course, it doesn't work on Windows because it's only cloudy on Windows. And on Tuesday, Christina said, understanding what is happening in a distributed system is hard. And yes, she was also being modest because it's really hard. So to figure out what is happening in a Condor pool or Condor system, there's a lot of sources of data you can look at. And I'm going to talk about some of those and focus on some of the new things we've added in tools and mechanisms along the way. So you can look at the job event log. You put log equals some job event log in your submit file. There's also class adds. So class adds have key value attribute pairs. There's job class adds that have about 100 or so attributes about your jobs. There's slot adds that have 70 to 100 attributes about what's happening in that slot, description of the machine, description of a job running on that slot. There's class ads about all the services or daemons that are running. Are they loaded? Are they idle? What version are they, et cetera, et cetera. Where do you find all these lovely class ads? So I'm going to talk about 3 different places. First, the active job database. This is the jobs that are in memory in the SCED. You typically use Condor Q, and you can see information about those ads. The access point also has an archived job database. So when a job is no longer active, the access point writes it out into a database called the history database, and you look at it with, for instance, Condor History. And then there's also a lot of classified ads inside of central managers that are inside of collectors that are running on the central manager and also running at the CE. So we'll first talk about the active job database. So, Condor Q. Condor Q has a new flag. Who here has used the -AF flag with Condor Q? Over half, probably 3/4. This allows you to customize the output that Condor Q does. I want to see the value of this list of attributes. But we've had a lot of requests of, we just want to see the normal standard output, the default output that Condor Q gives, but just with one additional attribute. And that's exactly what append auto format does. So you get the same output you always get, the same fields, but if you do -AAF, it appends a column at the end. We've made improvements to Condor Watch Queue. It's improved for viewing information about DAG jobs that you have. It differentiates jobs that are active versus jobs that are archived or completed. And you no longer have to press Control-C to exit it like it was 1981 or whatever. You can press any key. The HTCondor non-verb tools have received several enhancements, and there are more coming this summer. So we haven't quite thought of the name, but HTCondor job list report status, we're not sure. This will incorporate all of Kashika's work that you saw earlier today to get aggregate information about a list of jobs. We also added a bunch of tools and nouns and verbs for DAGs. So there's HTCondor DAG status, where you get a screen full of information, including how much of it is complete, how many nodes in the DAG have failed, so on and so forth. There is a DAG resources command, which shows you the resources, the slots a given DAG is using, along with information like your memory utilization on average. There is a DAG histogram. This is something the LIGO folks have been asking for a long time. So it just draws it on the terminal, similar to how Kashika's her work is doing. And this shows across time, and it's a little small to read here, but like green is done. So as time marches forward, more and more nodes or jobs are done. Blue is the little running. Our jobs transferring in, transferring out, idle or held. You can give, for instance, a command line flag -instant to the histogram, and this just shows the difference, what changed between each time unit. So all these blank spaces means nothing's really changed. No new jobs have started running. No new jobs have completed. No new jobs have done anything. But where there are lines, you can see where things have changed. To move a job from the active database to the archive database, typically this happens when the job completes, right? It might happen when you remove it as well. Now, historically, when you remove a job, that just kills it right away, and you don't get any of your output back. So if you're not on a shared file system, whatever output or standard out or standard error your job had produced up to that point is lost forever. People didn't like that. They sometimes want to see, well, I know my job is messed up and I want to remove them all, but I'd like to see where it was messing up, before you blow everything away. So there is a minus transfer option now you can give to Condor RM, which will transfer back everything as it kills it. So let's move to the archived job database at the AP. So this is typically you would use Condor history to access this. The archive is a snapshot of all the job class ads that have left the running state. So if it's gone to completed, there'll be a snapshot in the archive. If it's gone to removed, there'll be a snapshot in the archive. If it's gone from running back to idle, there'll be a snapshot in the archive, which is kind of interesting. So you can see what happened at every epoch. And you would use Condor history to access this. Now, Condor history sometimes requires a lot of patience to use because it must parse flat files to find a specific job ID or a list of job IDs. And these files rotate. So it can be very slow for old jobs. I personally am not a fan of waiting for my computer. That makes me annoyed. And it also hurts the effectiveness of other tools meant to improve the user experience, like, for instance, Kashika's tools she showed you. She mentioned it can use Elasticsearch or the AP job archive, and she mentioned, well, it's pretty slow using the archive. Well, hopefully the archive librarian will improve that. So the archive librarian was work performed by another fellow that was here last year, Sandy Nayar, and you can read her report in this tiny URL. But the archive librarian, you enable it on the AP, and we'll probably enable it by default once we're very comfortable with it by doing use feature librarian. And it maintains a little database, a little SQLite database that is basically pointers, or you can think of it as an index into where all the job history records lay in this big flat file or series of flat files. So, I tried it out myself on a very busy AP without the librarian. I think it took 2 minutes to come up with the job ad for a job that completed a couple days ago. With the librarian, it was, a tenth of a second or something like this. Condor Ad Stash. Condor Ad Stash is a tool that takes job class ads archived at the AP and pushes them along into Elasticsearch or OpenSearch. I know several of you are using it. So if you have a big enough and capable enough Elasticsearch instance, it's a great tool. And there have been improvements to AdStash that are up in the slide. The big ones are there's now options to have an allow and a deny list of attributes. So you can have a projection. So you don't necessarily have to store every single attribute. You can say, I know I will never ask what if questions about these 10 attributes and save that space. And how AdStash goes about making index mappings is more robust, less likely to cause pain and suffering. For instance, it automatically knows now how to deal with nested class ads as attributes. It knows how to increase the index field limit, which I believe it defaults to like 1,000 in Elasticsearch. And we certainly have, we've exceeded that, for instance, at CHTC. So it automatically increases it so you, the admin, don't have to do that. So what about ads that live in the central manager, collectors? So live information about the pool or site. You would typically use Condor status to query about this. So let's say I want to use this information in the collector to find how many slots are running a job. So I just want to count all the slots in my pool, all the execution point slots, where the state of that slot is claimed. So it's claimed by a user and the activity is not idle. So I could do Condor status and do what Marone hates what I do, which is pipe it into all kinds of Unix tools. And I may or may not get the right answer. So Condor status, grep, for claimed, and, the output of Condor status is subject to change, so this might not work. It might give wrong answers. Maybe I have a machine that has a host name. It has claimed somewhere in the title, or the host name of my machine is title. I don't know. So it'll give the wrong answer right there. This is also wrong. Maybe my name is Todd claimed. Who knows? So you can get around this using Condor status by using, for instance, the auto format option, the constraint option, and it's basically like a query. You say what types of ads you want to look for, what constraint you want on the ads, and what fields you want displayed. So you can do a little better than my first attempt. So how about a question of how many CPU cores are currently being utilized? This one's a little trickier. So I can say, okay, these are the slots that are claimed and not idle. And I just want to see how many CPU cores are in that slot. And what I want to do is for all the numbers, then it spits out, I want to total them up, right? I want to take a summation of all of them. And I could use a little tool like ST, which is simple statistics, which reads standard in and gives simple statistics like the sum. So yeah, now I can answer this question. There's 10,410 CPU cores currently being utilized. But of course, what I want to do is graph this over time. So I could have a cron job, right, that runs this little script I made, runs it once a minute. And what if I have hundreds or thousands of these metrics, right? So now I'm going to have a little cron job with a script that does 1,000 or 2,000 Condor status commands and stashes them somewhere. And then the collector is going to get unhappy. And wouldn't it be better if there was some service out there that would query the collector just once and figure out a projection of the attributes it needs to compute all the 1,000 metrics I'm interested in? And the answer is yes, there is. And it's called the Condor GangularD, which queries a set of collectors, filters and aggregates attributes, and converts these into metrics, and then forwards them off to Gangula. There's just one problem. Nobody is installing Gangula anymore, right? Who here is using Gangula? Okay, kudos to you, because I personally like Gangula, right? There's nothing wrong with Gangula. In fact, it's a great tool. The thing is, nobody is really making new installs of it, partially because everybody is addicted to Grafana because it has a dark mode. But, woe is me. So what we've done for 26 is we have converted the GangularD to the metric D. And the metric D does all the same stuff, but it has configurable backends. So it computes all these metrics. It can give the metrics to Gangula, or it can give the metrics to Prometheus, which supports Grafana with dark mode. That's the big change, and that's coming, for version 26. But do people think there should be other backends besides Gangula and Prometheus? I feel like if I had asked this a couple of years ago, people would have been like Graphite, Influx, but I feel like all those people have moved to Prometheus, so procrastination wins once again. Anybody feel there needs to be something other than Prometheus at this point? Yeah. Yep. Okay. I got a story there, but we'll wait for that. The metric D, it supports gauges, it supports counters. These are values that monotonically always increase. Okay, so for instance, a gauge in the start D might be the current amount of memory in use. A counter might be the number of jobs that have ever been activated on that start D. Supports both of those. It can do aggregates of counters. It can do labels in Prometheus. And there's a Prometheus exporter that just appears on the default Condor port of 9618. It supports IP address allow deny, HTTP basic auth. If you want something more fancy than that, you can just put a proxy in front of it and have whatever rules you want. So some example metric definitions. I'm going to name this metric CPUs in use. I want to look at machine ads. I want ones that are claimed and not idle. And I want to sum the value of the CPU attribute. And I'm going to make a second metric, CPUs not in use. And it's going to be, the requirements is the opposite of the in use. And I just drop these two metrics into the metric.d configuration directory. And voila, I now have everything I need to make historical graphs in lovely Gangula or in dark mode in Grafana of CPU core utilization over time. Now, anytime I show a graph like this, some people that are used to drilling PhD students that like to wear orange will ask questions. And they'll ask questions like, well, what is all this not in use? Why are these CPUs not in use? So you could have some additional metrics. Well, sometimes, CPUs might be in use because there's no memory on the machine anymore. There's less than a gig of memory on the machine. Or maybe because slots are in drain state, or maybe 3 or 4 or 5 other reasons. And you can end up with another graph like this of unused core reasons last week, right? Which lets you know why CPUs weren't being used. People are more concerned about memory these days than CPUs. So we can make the same memory utilization graph that we did of CPU utilization just by swapping out the value in the metric from CPUs to memory. Everything else is the same. A couple more little metric D examples. That was all memory provisioned versus not provisioned. What about utilized? So in the slot ads that the execution point is publishing, it publishes both the memory provisioned in that slot, but also the memory being used by the job. And by used, I mean, what is it using? The resident set size, typically. Convert it to a percent, and here's kind of your memory used versus provisioned as a percent across the cluster last week. Looks like we're averaging in the upper 40%, maybe not great. So you could enhance this metric to say user memory efficiency. So now I want basically the same information, but I want it for every user. And all I need to do is put a label, because Prometheus supports the idea of metrics that have a label on it. So I can say label, give a user label with the remote user. And then there are no labels on Gangula. So I have to convert the name. If you give Prometheus or Gangula as a prefix in front of any of these things, then it's specific to that backend. I'm going to kind of stuff the label into the name in Gangula, because that's the only way to do it. And now you have all the data you need to show memory utilization per user. And you could do this in Grafana as well. So all of the metrics that are in the CE dashboard, which we talked a lot about last year, are collected with the metric D. And speaking of the CE dashboard, Matt has been adding graphs. And one he's currently working on, now that the metric D supports counters, is network utilization at each site. So in the CE dashboard, this is Montana State, and it looks like it's doing about 23 terabytes per day of data coming in as input to Montana State. All right. Switching topics, scheduling and the matchmaker. There's lots of scheduling algorithms and mechanisms in Condor, including a user fair share policy. You can use Condor user prio to set a floor and a ceiling on what a user is able to have. So, oh, it's, it goes up or down based on fair share, but you should never go below the floor and you should never go above the ceiling. And now there is a lease involved on this. So you can give a duration which says change the Todd ceiling to 12, but then after this amount of time, go back to whatever it was. That was a much requested feature. So as I mentioned, there are many scheduling mechanisms in HTCondor. Counting groups, backfill slots, fair share, ranks requirements. And we've added a desperation-based priority scheduling as well. We use AI inference to process, do image processing, look at the eyes. Are they red? Are they teary? Is there yelling, screaming, swearing after jobs go on hold? Or is there, I forgot about those jobs. I don't even care, right? And based on that information, Condor can up or increase or decrease your priority. I fit into the yelling and cursing. I'm not sure about the crying, maybe. Also on scheduling, we have a preview of a mechanism we call owned capacity units. Marone mentioned this briefly on Tuesday, but the idea is it's a slot with a defined set of resources that is owned by a specific user or project. And other people can use it when that owner or project isn't using it, but when the owner wants it back, they want it back within what, just like that? Or just like that, Greg says. I think that is defined as 5 minutes or something. And one thing that's a little different about it versus just making a slot, a static slot, and putting a rank expression on it saying, I want this specific owner, is if the execution point hosting that slot disappears, the access point will work to replace it from a different execution point. So that's kind of nice. The annex, we have some changes there as well. So we talked last year, the year before, about using HTCondor Annex Create to glide into a preset menu of NSF HPC sites, NCSA, Purdue, SDSC. Frank would say, of course, SDSC. And if you wanted to use like the Slurm cluster on your campus, too bad, so sad. That wasn't an option. We are changing how Annex Create works. So now when you say, I want to create an annex, the result is you get a tarball, okay, an annex package. And the idea is to move this tarball to your Slurm login node, however you want to, untar it. Inside of the tarball, there's a README file. There's a sample Slurm submit file that you can just run sbatch on. There's a tool to make sure you have all the latest EP binaries on your system. You just run it and it says, okay, done. There's a token that allows it to authenticate back to the AP. This is just all inside the tarball. Edit the Slurm file however you like. Get more GPUs, less GPUs, pick whatever queue you want. Sbatch it and profit. The EPs will then run on your Slurm cluster, report back to the AP, and pick jobs tagged for that annex from that user. All the logs are available and visible to the user. And you might ask why the change, right? Well, for one, we want you to be able to use your campus Slurm cluster. Two, you might have heard in Ian's talk, sometimes, when using an annex, there's problems. And we don't want all these problems to be opaque to the end user. We want the end user to understand what's happening and be able to solve the problem themselves. So this is a step in that direction. Oh, Marone's turning on the mic.
Yeah, let me add here, putting all the specifics about the remote site into the access point was the right decision when we did it for clouds, but it's not the right decision when you deal with something like near, or because every time you want to change something about the target, you have to modify the AP, and the assumption here is that whoever who deploys the annex understands the remote system. So it was an example where the decision making was at the wrong place. So now, it gives the whoever deploys the annex more control. One thing that is missing in your slide, Todd, is that the gliding is now doing a better job in logging, and we hope to improve on that. It was there.
Well, no, but all the
No,
logs are available and
logs,
improved.
but these are, when you say all logs, you think about the logs that the execution point is creating. And the logging of the gliding were non-existing in the past.
True.
So I think some of it is also encouraged by or driven by the experience of Rubin of deploying things locally, and I think that JGI is also a potential beneficiary of deploying annexes on different Slurm systems.
Glidance. So glidance in the HTCondor grid universe is a way a lot of our DOE friends send glidance to machines. Typically, it's been of Slurm. Batch Condor, Condor delegates it to Slurm, which starts an EP, which then joins the pool. Especially in DOE, there's been a lot of activity to move away from SSH and Slurm commands towards REST APIs. So support for the NERSC Super Facility API has been added, thanks to Karan for jump-starting that from Pegasus. Support for the Flux scheduler, which is gaining popularity at Lawrence Livermore, with contributions from Ian. And this week, we were talking with our DOE friends about support for the IRI REST API, which is an attempt at an integrated resource infrastructure API across all DOE labs. And we're going to start looking at doing this at NERSC and then probably Argonne after that. Todd Miller talked earlier about common input data. So the amount of job input is growing, especially when you consider CIF files, container images and AI data. And many of these files are the same across all jobs in a job list or across all nodes in a DAG. So you have an executable like this, kitchen sink, Q1000. Today, every time a slot is activated by the access point, all the input files for the job are sent. So, job 55.0, boom, send this huge kitchen sink dot, container image across 55.1, 55. So we got 3 slots. We transferred that thing 3 times. So we heard on, was it Tuesday, Wednesday? Yesterday. It all blurs. We heard yesterday from Justin about how there's caches everywhere. And you can, on the EP, say you want to have a Pelican cache right at the EP. So now you have caching on the EP, and we're done. We don't have to transfer that thing over and over and over. Voila. Well, the bad news here is, one, the admin has to fragment the EP disk space between, I want to reserve this amount for the cache versus this amount is, whatever is left can be for the slots. What about data that's transferred not with Pelican? I mean, don't do that. Transfer everything with Pelican, of course. But let's say you're using Cedar. Let's say you're using a plain HTTP. That is not cached. Also in this model, data is stored twice. Right? It's stored in the cache and it's copied into the slot. And perhaps the worst sin is the AP doesn't really have any knowledge about what's being cached at what EP. The AP has a lot of information about the workflow, about what's going on. If Todd types Condor RM, it knows it isn't going to need that information anymore, as opposed to just a local cache that might hold on to it for who knows how long. So this was part of the motivation for Todd to work on common files. So this is the slide I showed before, moving input today. So with common files, the access point will move the kitchen sink file over to the execution point, and this will go into a data slot. All the jobs for cluster 55 goes into data slot 1. It then moves the CPU and the memory out of the data slot. So when you look at a data slot, it'll have 0 CPUs, it'll have 0 RAM. The only resource it'll be using is disk. It'll start up this slot with the CPUs and the memory, and then it'll make a hard link from the scratch space for data slot 1 into the execution slot 1 where the job will actually run. And as more jobs come along, well, then there's just more hard links for the file. Dealing with over provisioning of resources. We talked about last year, there is a retry resource request statement. So you can say, well, give me 1 gig, but in my big job list or DAG, I might have a few jobs that use a lot more memory, but I don't know which ones those are. So give everything 1 gig, and if that's not enough, then run the job again with 4 gigs. You can now do that with disk. And it's great that we have a lot of folks here doing astronomy, but what about astrology, right? So we now support in 26 astrological slot provisioning, and our test so far has shown we can improve pool harmony by 17%. You need to hand me your palm so I can figure that out. So MCP, we heard several talks about MCP. You can think of it as a port for an AI or a port for LLM. So your AI assistant, your AI LLM, instead of telling you, to figure out how many users are using the pool right now, run this command, and then cut and paste this command over, it can just do it. It can reach out and do it. You saw exploring uses of Condor MCPs from Brian's talk yesterday. And I think in the Atlas group, there was also a talk about MCPs for HTCondor, and I think we're going to hear another one tomorrow. So we're working a lot with MCPs. But AI is not the only big thing going on in computing. You can read on the Condor website how Google used quantum computing with HTCondor to assist in their quantum computing virtual machine, which they use HTCondor to run. So we added a quantum universe. You can just put this in your JDL. And no more job state confusion thanks to superposition. Is my job running? Is it held? When will it go into cooldown? When does it go back to idle? The answer is it's all of those all the time, right? So you don't have to worry about it. Well, no, but this is a good thing. The observer effect allows us to do transparent job migration again. No more draining of slots, draining of machines. You just do a Condor status to observe the job running on the EP, and poop, it'll just move to a different EP as soon as you try to observe it. So we have transparent migration. In addition to quantum universe, and perhaps just as murky, we've been looking at open on-demand integration. Cole talked about that. We've been working on reproducible builds. This is something that is now required by Debian and encouraged by several of our other downstream Linux distros. This is probably partially a result of all the security issues going on, supply chain attacks, so on and so forth. It's a little harder than you would think. You know, we put the build date in there, you know, we can't really do that anymore. We put the full path to the source code. We can't really do that anymore. So there's some changes. There's other challenges you can read about here. Container improvements. You can now have C group support for local universe. So when you submit a local universe job, you can set request memory, and then the AP will use C groups to enforce that. SSH to job works better with containers in more situations. We can work with containers that are targeted to use AMD GPUs with ROCm. And we have a Condor DAG checker. I'd like to think of this as lint for DAGman, for those of you old enough to remember the lint tool. Not only does it check your syntax and make sure everything is kosher, it also gives useful statistics. So you can run this before you place your DAG. And that is my talk. There are questions I'm happy to answer, or we can move right into our next and final of the day joint session. Questions? Cole, the man with the tie. Who are you?
Weather control be able to handle vacation?
Of course it will. Yes. Brian.
Set up the next.
Oh, Brian needs a mic.
So for the metric D, some people might be a little reluctant to open any HTTP facing ports. Are you thinking of adding it so you can just drop it to a flat file on disk so the Prometheus node exporter can pick up for those of us that have existing node explorer setup?
Yes, it is in fact sitting as a flat file on disk. The prom file is already there.
There was a suggestion from a user online. Rafi Rubin says for backends, there would be, for the metric D, would be interested in Kafka, Kafka,
Okay.
or other common conduits.
Kafka or other what?
Common conduits is what he says.
Okay. Who here would be also interested in Kafka? Okay. Great.
Okay, well, that's it. Let's get a big hand for Todd.